Here we go. We are live. Tyler, what up?
Same thing last time, man. Same thing.
Okay. Well, guys, I hope that you guys have an amazing day. So welcome back to Two Men, One Course podcast. Tyler and I are the hosts. Yo.
Welcome back.
All right, I got a question for you, Tyler. Number one, do you know that the first French fries weren't cooked in France?
I know where they were cooked, though. They were cooked in Belgium. In Belgium.
No, they were cooked in Greece.
Okay, I had a trivia question on that at trivia 2 nights ago, and they told me Belgium. So one of you guys is wrong.
Well,
sure.
I'm wrong.
Oh, I see what you're saying there. Jesus Christ, Tyler. Okay, they're from Belgium, cooked in Greece.
In Greece.
You got me.
Okay. All right, one more.
Okay.
What do you call a teacher who never farts in public?
I didn't know that was a joke. A teacher who never farts in public. Not you.
What is that?
Dancing queen. I don't know what that is.
We call a tutor. A tutor.
That was a great one. Wow. Great one.
Well, at least I got you one time. French fries. There we go.
It was good. Yeah, anyway. You got me with fries. That was way over my head.
All right, so we're gonna start right here. So properties of water. So water is an amazing substance and amazing in many ways. For example, so water have these properties: high heat capacity, high heat of vaporization, universal solvent. Everything's dissolved in a lot of things dissolve in water: DNA, glucose, cell, everything. Appropriate density for other properties from other applications, some reactivity, high cohesive adhesive forces, and high surface tension. You might be familiar with this, Tyler. What do you call this bug? Floating bug? What do you call
it? I don't know. Water bug?
Is it water bug?
I don't know
what it's called. No, anyway, so water has high surface tension. So this bug can stay on, can walk on water. Like human can walk on water like ninja.
Similar to the game Sink the Biz, for any of you guys who know what Sink the Biz is, that's because of the high surface tension of water. Just saying.
Anyway, so we're gonna focus on one property of water. The first one, high heat capacity. All right. You know what heat capacity is?
The ability to retain heat. I don't know.
Good job. Close. So all right, let's say I just give you some example. If I have the same mass of water and iron, okay, and I heat these two substances with the same amount of heat, do they increase the temperature the same way?
I mean, not imagine, no.
Yep. Which one gonna be hotter?
The iron, right?
The iron, of course. The iron is gonna be much hotter, and that's because of water has much higher heat capacity than iron. All right, let's take a look at the definition of the heat capacity. Okay, in the general chemistry textbook, we have the word specific heat capacity, same thing, which is the energy required to raise the temperature of 1 gram of the substance by 1 degree Celsius. Here's the example. Let's say if I have a water, I have aluminum, an iron, and carbon. Right? Look at the heat capacity. It takes about 4 joules to raise 1 gram of water by 1 degrees. It takes much less heat compared to other substances, about 5 to 10 times higher. So water can absorb and retain much of heat. Does it make sense? Yeah, 5 to 10 times compared to other substances. We have this formula. So heat capacity S equal to Q, which is the amount of heat per 1 gram per delta T. Delta means change. Have you learned that in school? Delta change.
Delta is change, yes.
Yeah, mean change, but delta T. So amount of heat that make 1 gram of the substance change temperature by 1 degree. Basically, if you move things around, so the students see this in the textbook. Q equal to ms delta T. Q is the heat. Okay. Now, the high specific heat capacity of water is actually a lot of time is a good thing, right? Think about this though. In our body, our human body contains over 70% water. The if you compare to like you might if you go to like a like really hot state, like let's say Arizona, or the concrete or the car surface is hot enough that you can boil or you can cook eggs, right? But that doesn't happen to our human body. At 100 degrees, we can still walk outside because we have a lot of water in it, so it absorbs the heat from the sun. Okay, and that our body can retain the temperature at about 98 degrees Fahrenheit or 37 degrees Celsius, and that makes our enzymes, cell, DNA function properly. Because the body temperature doesn't change that much, which is a good thing. Okay. Anyway, so this lab, what the student gonna do? The goal is, so we're gonna use this heat capacity of water 4.184, this number, to determine the heat capacity of an unknown metal. They have to figure out the what metal that is. Yeah, so they're gonna have the unknown metal, a few test tubes, a styrofoam cup. That's a calorimeter. That's how it's like instrument to measure the heat. Thermometer, Bunsen burner, and a beaker. Have you used a Bunsen burner in school?
Back in high school, man.
Back in high school.
Yeah.
Okay. Anywho, so they're gonna do something about this and come up with the heat capacity of the unknown metal. The only law that they're gonna use is heat in equal to heat out. Okay. For example, the basic law of conservation of energy. If I have two objects next to each other, on the left one is hot, on the right one is cold. What's going to happen to them if you put them close next to each other? Can you guess?
I mean, the hot one will warm the cold one, and the cold one will cool the hot one.
Good job. So basically, he's going to go move from the hot one to the cold one, right? So the hot one, we can say that it's losing heat, negative Q, and the cold one, you get positive Q, which is gain heat, right? Does that make sense to you?
It does. Now, does that matter what the outside temperature is?
Oh, it matters, dude. But this one, just keep things simple. Just these two, not like the outside temperature. Yeah. Another example, if you put an ice to a hot cup of tea. Now, I'm going to ask you this. Who gains heat? Who loses heat?
The water gains heat. The tea loses heat.
Good job. Yep. So the ice gonna gain heat, right? So that's why it melts, and the temperature of the tea gonna be lower. So that's why we use this sign right here. So positive Q of ice and negative Q of tea. So tea loses heat and ice gains heat. Okay. So basically, this is what we're gonna do. The goal is to determine the heat capacity of that metal. Okay. So we're gonna heat it up. So this metal contains some heat. I'm going to use the QM. M stand for metal. Q is heat. So this metal contains some heat. And we're going to put this metal into a calorimeter, which is styrofoam cup containing water. Drop in there. Okay. All right. Now I'm going to ask you one more time. Who gains heat? Who loses heat?
The metal will lose heat.
Good job. Yep, that's it, right? So now the metal is going to lose heat. Who gains heat though?
The water.
Is it just water?
The cup.
The cup too. Good. So the cup and the water. So basically, the calorimeter, we use the calorimeter as the heat trap. Does that make sense?
To an extent, yes.
Yep. To some extent. Good job. So we can write an equation like this. So heat out from the metal, go to cold water, and go to calorimeter. Right. So this is loses heat, the negative sign, and the positive side said that's gains heat. Does that make sense?
Yeah, I mean, I don't know these formulas or anything, but I don't have the book. So hopefully, students, you should be reading this so you know this better than I do. I'm just here to talk about the styrofoam cup, man. That's all I got.
Okay, good. You get a styrofoam cup, it's fine. All right, I'll explain it to the student. All right, basically, so Q right here is equal to ms delta T. You saw it earlier. The S M right here, that's a metal. That's a heat capacity of the metal that we want to determine. All right. You can do the same thing on the right side, or the ms delta T. This is all cold water, and also calorimeter. So C, heat capacity of calorimeter, and delta T. All right. The heat capacity of water, we know that we talked about earlier. So 4.18 joule per gram per degree Celsius. And before you can determine the specific heat capacity of the metal, we have to determine the heat capacity of the calorimeter first. Okay, that's going to be part one. And there are two parts in this lab. Part one, you're gonna determine the heat capacity of the calorimeter, and then use this number to determine in part two the heat capacity of the metal. All right. So basically, this is what you're gonna do. All right. Part one, determine the heat capacity of the calorimeter. You have 4 test tubes. The first test tube, you add about 30 milliliter of water. The other 2 test tubes, 20 grams and 40 grams of metals. Okay. You're gonna set up the heating station. We have wire gauge right there. Put a beaker onto it. Add water. Ta-da. All right. Now you're gonna put all the test tube in there and heat it up with the Bunsen burner. Heat it up, heat it up, heat it up. And you're gonna use the thermometer to see like what temperature those are. Okay. Let it equilibrate for a while. You want to make sure that all water and the metal are in the same temperature as the water outside. Okay. All right. Next one is gonna happen. You're gonna take the beaker, put a styrofoam cup in there. That's your calorimeter. Super simple there. Add 70 milliliter of water and a thermometer. You're gonna measure some temperature there. That's the initial temperature. And then this is gonna happen. You're gonna take a test tube number 1 and pour the water in it. You're gonna see the water goes up. This is hot water, so the temperature of this system of the calorimeter goes up as well. Okay. In this case, we can say that the hot water will lose heat to the cold water. So cold water add heat gains heat right there. But not just the cold water, the whole calorimeter also gains heat. Okay. All right. Now for Q right here, we can do MS delta T from all of them. All right. Now you're going to determine the heat capacity of the calorimeter. So which means that you have to know the rest of the number, the terms. The mass of the hot water and the cold water, you can measure it with the balance. The heat capacity of water is 4.18, right? And the temperature right here, or delta T, do something about these 3 numbers. You can figure out the delta T. And that's how you get the heat capacity of the calorimeter. Repeat this experiment one more time with test tube number 2. And that you're gonna get the average, the heat capacity. All right. Once you get the heat capacity of the calorimeter, you're gonna move on to part 2, determine the specific heat capacity of the metal. So we have test tube 3 and 4 left. Okay. All right. So we're gonna take the test tube 3 and then add the metal in it. Of course, this is hot metal. So do you see the temperature change again? So increase the temperature. And now we can say that, well, the hot metal loses heat, negative sign right there. And the cold water and the calorimeter gains heat. All right, change term real quick. So MS delta T from all of them. All right, so we're going to determine the specific heat capacity of the metal, which means that you need to know the value of the rest of the term. The mass of the metal, you measure with the balance at the beginning, right? Mass of cold water with the balance as well. Heat capacity of water, 4.18, and heat capacity of the calorimeter, that's from part 1. And you can solve for the specific heat capacity of the metal. That's it. And you repeat the same experiment with test tube number 4. And that's it. Yep. Tyler, really get it. See? Oh, thank you. Thank you. Give me a applause. All right, so that's pretty much it. We'll go have fun in the lab. All right. So before we close this podcast, always. All right, Tyler moments.
Are those the same pictures as last time?
Yeah, last time. Yeah.
Those are fabulous.
Those are the best picture of you. Like you look the best, man.
I know. I'm not sure what happened over the course of the last 31 years, but it's going like this.
This is on the right side is like 6-year-old.
This was I do remember this day. This was 6th grade with my puka shell necklace, and I had the spiked tips like they did in NSYNC. And they were highlighted. I bleached the tips of my hair.
Oh, you did. Right. I can see that. Yeah, you
This
did.
here in the middle was in Orlando. This was right actually before I had dreadlocks, unbelievably.
18.
Um, at
Yeah,
the University of Central Florida, and then this one here obviously is more recently.
yeah, recent month. Okay. I gotta say you look better.
Thanks, bro.
All right, so we would like to so talk about something that we can relate to college students and many other people as well. So Tyler would like to introduce you the word stress. Take it away, Tyler.
Tyler wouldn't necessarily like to introduce this to you, but it's something that, well, Pete, you were asking me like, what do you want to talk about? What's relatable to them?
Well,
And I said, I don't know, mental health. And you said, well, man, I'm stressed. And I said, bingo, there it is. Stress. I said, stress is what you're feeling. Stress is what we're going to talk about.
Okay, stress. All right, is stress a good thing? A bad thing?
It can be either. In and of itself, it's not a bad thing. It's the thing that keeps us safe. It's the thing that keeps us organized and on task. But it can be, right? So it's not, I mean, you've got something here, like it's not a mental illness in and of itself, right? It's not like anxiety or depression, which are diagnosable mental disorders. Stress can be part of either of those diagnoses, as well as a myriad of other diagnoses. But in and of itself, it's not necessarily a bad thing, and it's not a mental illness. However, it can prohibit us from, doing things in our day-to-day lives that we actually want to do or that need to be done.
I see. Okay. We have a little definition of stress. That's a long one.
That's not a little definition. That's a real definition. Let's see what else you had. The brain there is really fabulous.
Thank you. The brain.
Yeah, the prevalence is interesting there. What you see there is that there's going to be a higher prevalence. Prevalence is basically the frequency throughout a population. So there's higher levels, tends to be higher levels of stress in populations who are subjugated in some way, right? So you've got the LGBTQ, you've got people of color, you have people with a disability have hugely high indicators of stress. Surprisingly, healthcare professionals, myself, or people in primary or tertiary healthcare, where they're working in hospitals, have a lot higher levels of stress. Students, kind of like we talked about last time, with higher levels of anxiety, stress is there too, right? Like Pete, you can understand that, man. You remember studying for tests or like staying up till God knows when trying to write a paper, just like stressed as can be, trying to pull my hair out. I mean, I still have nightmares of those days. So it's a thing that, we all deal with. I like how you threw cortisol on here. Cortisol, I guess you guys will talk about that in class. It's one of the easiest and most accurate ways to test someone's stress levels. You do like a mouth swab, a saliva swab, and you can test their cortisol levels. People with higher levels of cortisol tend to have higher levels of stress.
Like from your mouth, really?
Mm-hmm.
Wow. Okay. I thought you have to check blood or something.
Nope. You can do it in your mouth.
Really interesting.
Super easy.
Wow.
They're doing it now in the field for a lot of new research studies. They're using cortisol swabs in the field.
Okay. Sounds good. Okay. Now, if you have stress, let's say in college, what's the best way to combat stress?
Well, the best way, it depends on who you ask, and it depends on the person, right? In my opinion, from a recreational therapy standpoint, there's two things, the same really two things that we talked about last week that are going to be, the best for managing stress. And that's physical activity and being outside. Physical activity is going to do everything for you. The being outside is really interesting now. And I'm going to get a little theological on you guys. There's this theory called the biophilia theory, which basically states that because humans, for most of our existence, lived with nature, right? Until the last 300, 400, 500 years, we were in nature, right? There was no buildings, there was no electricity, all this nonsense that we have now. So now that we've kind of been thrust into this, this dystopian future, we are experiencing higher levels of stress because we are no longer in with nature, in with where we were for the last thousands and thousands of years, right? So along with this theory, comes the fact that, you know, being outdoors does tend to decrease levels of stress. Okay. You know, and there's other things, right? What else do you have on here? Activities. So like finding a hobby, man, find something that you enjoy, find something that can take your mind off of the day-to-day, the mundane tasks that you have to do every day that cause you stress. So for me, like I would play guitar, or I'd go out and play disc golf, or I'd go to the gym. Aromatherapy is kind of an interesting novel approach to managing stress, right? There's things like chamomile and rose and violets. These things are all used. There's actually therapeutic professionals that use aromatherapy, but things you guys can get essential oils at home. Reading, journaling is a fabulous one. So, I mean, there's a slew of things at your disposal. It's just kind of trying them and finding what works.
Does going to a bar count as a going outside?
You know, and that's interesting, and it depends on the bar, and it depends on the environment.
Okay, all right.
So there are, here in Indianapolis, there's a couple of bars that are like, I don't know, they're outdoors and they're like game bars. It's like a brewery, right? So you go there, and for instance, one of them is at a dog park. So you're out there with your dogs, you're playing cornhole with peers. So I actually take clients there doing some type of community integration, right? Now, going to a rave is probably not a good way to manage stress. So pick and choose.
Pick and choose. Okay. All right. Well, thank you very much, Professor Niemeyer, for the insight about stress. All right. So last time, well, if you like us, well, don't forget to click like, subscribe, rate 5-star. Leave us a comment. So tell us how we do. And well, we'll see you next time then.